The second video for 2.5 is on horizontal stretching and shrinking. So we've moved on from the a value, which goes in front of the f of x equation, to a b value that goes in the bracket with an x. So this is a transformation on x. Anything in the bracket with x is a transformation on x. Anything outside the bracket is a transformation on y. So before we go into the details, let's just explore this a little bit on Desmos. So here is my basic graph of a y equals x cubed graph. Starts at 0, 0, goes to 0, or 1, 1, goes to 2, 8. You can't really see it up there, but let's just shrink out a bit. So then it goes over to 2 and up to 8. And same thing, symmetry over the origin. So you'd have a point -1, -1, and -2, -8. Now, I'm going to do a transformation on x. So to do that, I have to be very careful. I have to put the transformation in the bracket with the x. Oh, why am I not typing? Bracket. Oh, weird. One sec. Sorry about that. I have to go get new batteries. Okay, so we're going to put the transformation in the bracket with the x. So I'm going to go bracket 2x all cubed. All right, what happened? Well, something we didn't really expect to happen happened, maybe. So the red graph is my original graph, and the purple graph is my transform graph. What happened? From an x perspective, is the purple graph a horizontal stretch of the red graph or a horizontal shrink? Hopefully you're all saying shrink. In fact, if I put any value for b greater than 1, so let's put in a 3, it gets even more shrunk. So the larger my value for b is getting, the more my graph is shrinking or getting closer and closer to the y-axis. Does that make sense? Well, if you remember back to other transformations we've done in other courses, anything with x is opposite as it appears, and that's the easy way to remember it. So instead of multiplying my x values by 2, I'm dividing my x values by 2. Instead of multiplying my x values by 3, I'm dividing my x values by 3. And the reason this happens is that to solve for y, you want your y values to stay the same, right? This is a transformation on x. So in order to solve for y, you have to think about what you're putting in for x. Well, if I'm going to put in a value in here and get the same y value, I actually have to half the x value. So if I want to get a 1 in here, so 1 cubed is 1, right? If I want this point here, 1, 1. If I want to put this point and I want to get the same y value, 1, I have to put in an x value of a half, because a half times 2 is 1, and there I get my 1 cubed is 1. So I have to half my x values so that when they get cubed, I get the same y value. So same thing here, I'd have to divide them by 3 in order to get that same y value. So I'd have to put in a third for x in order to get that same y value of 1. So let's see what happens if I change this to being y is equal to a half. So what if I put a half x all cubed? So now, instead of dividing by 2, it's actually I have to multiply my x values by 2. So to get that same y value of 1, I have to put in an x value of 2, because 2 divided by 2 is 1, 1 cubed is 1. So this x value, this 0.11, to get this point something 1, I actually have to get 2, 1. If I were to put a third in here, let's just copy this. If I was just to change this 2 to a 3, I actually have to multiply my x values by 3 to get 1, to get that same 1 y value. Does that make sense? So the moral of the story is that everything with x is opposite it appears. If it looks like you should multiply by 2, divide by 2. If it looks like you should divide by 2, multiply by 2, and it'll work every single time. Also, be very careful that y equals bracket 2x all cubed is very different than y equals 2x cubed. One of these is a transformation on x, and one of these is a transformation on y, and you get different graphs. Okay, so this one in the bracket with the x is a transformation with x. Outside of the bracket, right, it's not getting cubed, is a transformation on y. Okay, so let's go back to the note and see what we can do. All right, so this is the Desmos, well, the written version of the Desmos thing. So you're supposed to notice here that the pink graph is the black graph horizontally shrunk. right? Because the x value is 2, it's been horizontally shrunk. I took all the x values, so this one was 1, now it's a half, right? This one was -1, and now it's -1/2, right? All the x values got shrunk towards the y-axis. So it's horizontally shrunk by a half. All right, so when b is greater than 1, the graph is horizontally shrunk. Whereas if I put in something like a b value of a half, something between 0 and 1, it gets horizontally stretched. Opposite as you would think. Horizontally stretched. Okay, so when you do the transformations, you'll notice that it goes in the bracket with the x. So remember when it was an a transformation, you multiplied the entire equation by 2, whereas here you actually put the 2 in the bracket with the x anywhere there's an x. So same thing here, 1/2 x, 1/2 x, or just if it's a function notation, just put 1/2 x. Okay, so the y equals f of bx can be obtained by dividing the x coordinates of y equals f of x by b. So some people think of it as, you know, dividing. I like dividing by b, so I take my x values and I divide by b. Some people think of it as you multiply by 1 over b, right? So you do the inverse of whatever it says. Whatever makes more sense to you, that's what you should stick with. So let's do some examples. So let's say I have a point 28 on the graph of y equals f of x. I want to find the corresponding point on g of x. Describe how the graph of the function can be obtained from the base graph. All right, so this one has a 2 in the bracket with the x. Again, you could think of this as x multiplied by 1 over b, or multiplied by a half, or you can just go x divided by 2. So anyway, I'm going to take the x values, divide by 2. My new point would be 1/8. Same thing here. It looks like divided by 1/4, so I know that I'm actually going to multiply by 4. Some people like to think of it as multiplied by 1 over b. I just find that gets like super confusing after a while. I'm all about the opposite operation, right? And if I do the divided thing, it would be x divided by 1/4, which would end up with x times 4. So any of those three, whatever works in your brain. I like opposite operations. So if I have a point 28, I'm going to multiply the y value by 4 because it looks like divide by 4. I think I said y, I meant x. So we would end up with a 0.88. Okay, last one. So this one, you have to recognize your base graph. So my base graph is x cubed. Where's the 3? It's in the bracket with the x. So I'm going to take my x values and I'm going to divide them by 3. So if I have a point like 2,8 and I divide my x value by 3, I wouldn't want to graph it, but it's now at 2/3, 8. I also said describe these. So this one I would say horizontally shrunk by a half, or you can just say horizontally shrunk actually. Okay, this one would be horizontally stretched. Let's just keep out the other part. If I was, it's going to be horizontally stretched by 4. Can't stop myself. And this one would be horizontally what? Because it's a 3, opposite as appears, it's going to be horizontally shrunk by 1/3. All right, let's look at some examples and then you can go practice the worksheet and the questions, select questions from the textbook. So for this one, y equals f at 2x. So again, it's a transformation on x. First thing I would do is pull out some key points. So I can see 1, 2, 3, 4, 5 key points that I'm going to transform. It's up to you whether you want to write them down or not. Some people just transform it right on the graph. This is a new thing for me that I've started actually writing out these key points, and I find it really helpful for students. So this point's -1, -1, 0, 0, 1, 1, and 2, 0. Okay, to each of these, I'm going to take the x values and divide them by 2, or I'm going to multiply them by a half, whatever you want to think of. Okay, so all the x values, I'm going to divide by 2 or multiply by a half. So this one's going to be -1, 0, and I would plot it as I go. So -1, 0. This one's going to be -1/2, 0, or -1/2, -1. So it's going to go -1/2, -1. So the y values aren't changing, right? It's only a horizontal shrink. 0, 0 will stay 0, 0. It's one of those what we call invariant points. They don't change. This point, again, multiply the x value by a half or divide by 2, and I get a 0.1/2 1. Such a nice scale. And then lastly, multiply the x value by a half or divide by 2 and I get 1, 0. So this point comes into 1, 0. So my new graph is going to look like this. It's the same graph, just horizontally shrunk by a half. All right. Pause the video, give this one a go. Again, I drew your base graph for you. This is y equals x cubed. When you go to do your homework from the textbook, you're going to be expected to know these, but key points, maybe before you pause your video, would be these ones here. Those, and this guy. So I would pull out -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. Okay, and then do your transformation on them. So hopefully pause the video. So it's opposite as appears. So I'm going to multiply all my x values by 2 or divide it by a half or multiply it by 1 over 1 over 2. I don't know. I like this. So I'm going to take all my x values, I'm going to multiply them by 2. So I'm going to get a point -4, -8. So it's going to go over to here. I'm going to have a point -2, -1. So this is going to go over to here. 0, 0 won't change. So it's going to stay here. 1, 1 will become 2, 1. And this would become 4, 8, 4, 8. And again, you don't have to write out these points. I could have just taken these key points and multiplied the x values at the same time. So this 1 becomes a 2, this 2 becomes a 4, this -1 becomes a -2, this -2 becomes a -4. Totally up to you. And then I'm just going to copy them. Now, when I made this graph, the base graph for you, it didn't put the arrows on the end, but I want you to know that these graphs both keep going, right? I've just shown a representation of some of the points on the graph. All right, and so this one would be a horizontal stretch because the b value was a half. All right, go and practice those.